Section 6.3 of the guided notes. If a function is quadratic, it can be represented by the equation of the form ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. This is called basically the standard form. Standard form of the quadratic equation, something you actually are already familiar with. And the axis of symmetry for a quadratic equation in standard form is given by the equation x is equal to negative b divided by, let me move this here. I just don't like the way x is equal to negative b divided by 2 times a. And the vertex of the quadratic equation in standard form is given by this. Essentially, whatever negative b over 2a is, comma, whatever f of negative b over 2a is. And that part's going to be confusing for a lot of you, but we're going to take a look at some examples, so try not to freak out, and it's all going to be okay. So we're going to work on an example right now. So if you have y plus 3x squared is equal to a negative 4. We're trying to figure out the axis of symmetry, right? So let's take a look at an example. Rewrite the function in y equals ax squared plus bx plus c. How come? This is the standard form of the quadratic equation. So, but you got a problem, right? This is on the wrong side of the equals. So you got to move it over there. And this all boils down to basically section 1.1 of Math 1 again, doing the inverse operations. So I subtract 3x squared from both sides, and you get y is equal to a negative 3x squared. Plus essentially 0x, right? Because we're looking for the b. And minus 4, right? Here's our a, here's our b, and there's our c. Sorry, that looks like a y. And these a, b, and c, these are all coefficients or constants with the variable. And now this thing is in standard form, right? Y equals negative 3x squared. Basically minus 4. So this is a quadratic function. And now let's try to find its axis of symmetry. Well, I already told you if the axis of symmetry is x is equal to negative b over 2a, well, right here I told you, let me do it in a different color, that b would be 0. So x is basically equal to negative 0 divided by 2 times a. How much is a? A negative 3. And you can see, well, it doesn't even really matter because 0 divided by any number is simply going to be 0. You get basically negative 0 over negative 6, which all winds up being 0. So what's the axis of symmetry? X equals 0. And that makes the vertex of this thing 0. And now let's try to find, here's x equals 0. Now we're going to try to find the y coordinate. And we basically take what we got from our axis of symmetry and plug it into the function. So y is equal to negative 3 times 0 squared minus 4. So, right, negative 3 times 0 squared is, of course, 0. So, when x is 0, y is negative 4. So, our vertex is going to be 0, negative 4. So, let's try another example, because I know this seems a little goofy, but these should be future posters on the wall. So now let's try some more, right? And we have to remember, right, we're looking for basically negative b over 2a, comma, let me write that a little neater. My a's are terrible. How do I make an a that doesn't look like a 9? Negative b over 2a, comma, and then f, negative b over 2a. And all that simply means is whatever I find here, whatever I find figuring this out, basically I plug it in to the function, and that gives me the y value, right? This is going to be our x value. This is going to be our y value of our eventual vertex. So let's give it a shot. First thing I got to do, step 1, convert to standard form. And right, if I'm looking for y is equal to ax squared plus bx plus c, well, this thing is certainly not in standard form. So how do I do that? Like, I've got to add 4x to both sides, and I have to subtract x squared from both sides. Right, and when I do that in standard form, I get y is equal to basically a negative x squared plus 4x. And then, right, this and this is going to cancel. And then there's no numbers. So c, this is basically plus 0. Here's a, b, and c. Right, a in this case is negative 1. B is 4, C is 0, and if I'm trying to find basically negative B over 2 times A, right, that's what this is. And but before I put it in parentheses, let's figure out what that is. So you basically have negative 4 over 2 times a negative 1, which is a negative 2, which makes this, of course, positive 2. So we've done two things. We figured out the axis of symmetry, right? For this, we're still on problem 6 right here. And we've also figured out the x-coordinate of the vertex. So our vertex is at 2. And then we plug in, basically, remember, whatever I find figuring this out, I plug it into the function. So what is y is equal to negative, basically, 2 squared plus 4 times 2. So you have negative 4 plus a positive 8. And that's 4. So that makes my vertex 4. And remember, the axis of symmetry is always the x-coordinate of the vertex. So here's x is equal to 2. That's the axis of symmetry for problem 6. So I'll give you a moment to write all that down, and then I've got to erase this mess, or I'm going to run out of room, basically, to do problem 7. Hopefully I left you enough room on your notes. Let me double check if I did or not. Oh, well, maybe you don't write as big as I do. So hopefully you can make it fit. So next up, number 7, I'm going to erase this thing here to give me enough room. So I'm going to erase all this. And now I'm going to try number 7. But this stuff still applies, right? So first step, convert it to standard form. So, but there's a problem with number 7. 7's not quadratic. There's nothing squared. So we're skipping example 7. That solves that. I don't know why they'd put that in the textbook, but it's a waste of your time. So we're not going to do example 7 for notes. Let's see what else is next. Here's my favorite stuff. Rewrite a quadratic function from vertex form to standard form. So if we have vertex form, that's this thing right here, right? This is in vertex form. And I can't spell form, right? That's clearly A. This is clearly H, and that's K. But now we need it in standard form. So if I had basically just x plus 2 squared all by itself, this would, if I follow the formula, a squared plus 2ab plus b squared from last chapter, and isn't it either good or bad that basically math just keeps building in complexity? That you needed the information from last chapter to do this part now. Or you could FOIL it. Foiling works. This becomes, x squared plus 2 times x, which is 4x, plus 2 squared, which is 4. So you basically have, we've expanded this part, x plus 2 squared. So you basically have x squared plus 4x plus 4 in the middle here. And now you have to multiply everything by a -3. So -3 times x squared, -3x squared, -3 times 4x, -12x, -3 times +4, -12. And all that is -1. So you can combine the -1 though, right? Because they are like terms. And what is -12 and a -1? That's going to be -13. So your final standard form, -3x squared minus 12x minus 13. Or same thing here, -3x squared minus 12x minus 13. And if you plot this into your HRW or Desmos graphing calculator, and then you plot this thing right here in HRW or Desmos, you'll find that they are the identical graph, right? This graph here still has it's still stretched by a factor. It's going to be stretched. Let me spell right. I don't know what's wrong with my brain. Probably because it's the first day back, a week off. Stretched by 3. It's been reflected just like the other graph. And H is still -2, and K is still -1. And I think this is a good exercise if you have time to basically graph both things. And ideally, you should see that they are the same graph. And why is that important? Because basically a standard form or vertex form are just two different ways to show the same parabola. So I think that understanding is critical. So now let's work on these, and I don't know why I gave myself such little room to work, but if I expand just the x plus 5 part, I'm going to get x squared plus basically 2 times 5 times x plus 5 squared. So in the middle here is really this. And this gets multiplied by 2 everywhere, right? Here, here, and here. So 2 times x squared is 2x squared. 2 times 10x is 20x. And 2 times 25 is 50. And then all that's plus 3. So the final version, 2x squared plus 20x plus basically 53. That's number 9. I guess I didn't need that much room after all. And now let's check out example 10. Right, so I know this here is going to expand to x squared minus 2 times 7 times x. So minus 14x and then plus 49. So all of this gets multiplied by essentially a negative 3. So negative 3x squared minus a minus and a minus right here and here make a plus. So that's going to be plus 3 times 14 is 42. So plus 42x. And then minus 3 times 49, well, that's 150 minus 3. So that should be minus 147. And then we can't forget about the plus 2. Right, those combine. Final answer right here, minus 3x squared plus 42x minus 145. So teeny tiny amount of space, but somehow we still made it work. Let's try the last little bit of notes. So in this next section, they're trying to show you that you could write basically the vertex form and the standard form using the data of a table. And let's see. So let's give that a shot. So here we go. Basically, here's a value for x. There's a value for y. They're saying this is the vertex. And right, these are also otherwise known as h and k from our vertex form. So you know that when x is negative 2, right? Well, before we get too far along, let's just plug in h and k. So we have y is equal to a times x, and it says h here is a negative 2, so this is going to be plus 2 squared, and k is negative 3. And let me, right, these are the coordinate values, but this is the vertex right here, the vertex. And that's all great, but what's the one thing in this equation you don't know, right? And that's the a. And the table doesn't tell you what a is either, but the table does give you is some values for x and y. Right, that was our vertex. So let's try another value, and we're going to try negative 3 for x, right? And what we're trying to do is we're trying to figure out a. So when y is 1 and when x is negative 3, when I plug it into this equation, which equation are we talking about? This one. right? You should get all these things. And now there's only one thing I don't know, and that's the a. So negative 3 plus 2 is negative 1, and negative 1 squared is 1. So basically, 1a is equal to 1 minus 3. And then we're going to use inverse operations. You get a is basically equal to 4. So if a is equal to 4, then the vertex form of this equation is like so. And now we can use this information to rewrite it in standard form. So this, right, so far we've done all this work. This is vertex form, right? Vertex form. To make it standard form, we have to expand this part, which means multiply it out. This is going to be x squared plus 4x plus 4, right? All times a 4 minus a 3. So, right, you got to multiply everything out to there, to there, to there. Right, this becomes basically 4 times x squared is 4x squared. 4 times 4x, 16x. And then 4 times 4 is 16, right? You're going to get 16 here, but it's 16 minus 3. So there you go. There's the standard form of the equation. And we used all that just starting with our table, our vertex, and a couple other pieces of information. So now you have essentially basically a standard form version and a vertex form. And the only way to know, or not the only way, but one of the ways to know if you did this right is when you graph this and you graph that, if you did it right, it'll be the same graph. But if you did it wrong, you'll get two different graphs. So that's a way you could check your work on the graphing calculator. If your vertex form and standard form, right, I should write this down. If vertex form, and I'm abbreviating, and standard form make the same graph, correct. If not, incorrect. One of them will be incorrect. So hopefully that helps. Hopefully I didn't lose some of you with all this work, but this will be the last guided notes of the semester, so that should make everyone happy. And then we're going to basically pick up where we left off in semester 2, and of course advance on all this knowledge you've theoretically learned in semester 1.